This is the Explanatory Model Analysis podcast about various techniques for explainable artificial intelligence. I describe methods for visualization, exploration and explanation of machine learning models. This episode is about the Shapley values and breakdown with interaction. I will show you how to use these methods with the Dalek package for the R language. If you are interested in examples for Python or other XAI methods, you can find other episodes at tiny.cc/Dalek webpage. Before we jump into the R code, let me summarize how these methods are different from the breakdown method presented in episode 3. All these methods are model agnostic and instance specific. It means that they work for any model without assuming anything of its internal structure, and they explain the model result for a single observation. The breakdown method is order specific. It means that for the different ordering of variables, we may get different explanations. In default settings, a greedy heuristic is used to identify the best order. Shapley values are defined as an average of variable attributions across all possible orderings. The number of orderings may be large, but we may estimate these values based on some random orderings. This way, differences between different orderings will be averaged out. The method breakdown with interactions identifies pairs of variables which are the source of the differences across orderings. It seeks for interactions between pairs of variables. Such interactions are then presented on waterfall plots. Let's see how to calculate these different methods in R. In this video we are focused on the software. If you want to learn more about the methods, go to the ebook at parbietrek.github.io/EMA. As in the previous episode, I will use the data for the sinking of the RMS Titanic and a classification random forest model trained with the Ranger function. The model is trained to predict the chances of survival based on available variables like gender, age and class. All three methods described in this episode work on the instance level. As the instance of interest, we use Henry, a 15-year-old boy from second class. The predict parts function by default calculates breakdown attributions. There is an interaction of fair and class variables for Henry. Depending on the order, one of these variables has a positive effect, while the other has a negative. If you want to calculate Shapley values, set the argument type to Shap. Optionally, set the B argument to specify the number of random orderings that shall be used for calculations. The result is a data frame with the attributions for different orderings. It is best to visualize this result with the generic plot function. For each variable, the Shapley values are shown with colored bars. Additionally, box plots show how the attributions for individual variables look for different orderings. In this model we have interactions of fair and class, so the box plots for this pair are very wide. If we want to draw Shapley values without box plots, then in plot function we should set the argument show box plots to false. This is the ggplot object, so you can use other ggplot2 functions to modify the plot, like ggtitle to add a title, or theme to change the skin. To identify interactions, the predict parts function must set the type argument for breakdown interactions. The result is also a data frame. As in previous cases, we can visualize it with the generic plot function. The general workflow for the predict part function is summarized in this sequence diagram. Depending on the type argument, the function calculates breakdown profiles, breakdown with interaction, or Shapley values. The result can be further processed with the generic plot function. Find more examples and more details in the Exploratory Model Analysis ebook. The list of all episodes is available on the website tiny.cc/Dalek. If you have any question or comment related to this topic, please let me know.